What's up guys, this is Massey. Welcome to another video. In this video I want to talk about Hess's law. I'm going to show you some examples, and I start from easy to difficult questions to show you how to use Hess's law in order to find out enthalpy change for the reactions. In the first question I have nitrogen dioxide can be made using a two-step process. The thermochemical equations for the two steps are N2 in gas phase plus O2 in gas phase is going to give us 2NO in gas phase, and delta H is positive 180 kilojoules. And on the second equation, you have 2NO in gas phase plus O2 in gas phase is going to give us 2NO2 in gas phase. Delta H is negative 112 kilojoules. The second one is negative, so we have exothermic reaction, so it's releasing energy. But in the first reaction, we have a positive number, so it means that we are dealing with an endothermic reaction. So it means that it consumes or it gains energy. So the question is, calculate the enthalpy change for the following reaction. N2 in gas phase plus 2O2 gas phase is going to give us 2NO2 gas phase. In order to find delta H for this overall reaction, we need to take a look to the previous two reactions here. So we have N2 in here. We have O2, and O2 is going to give us 2NO2. And here in final, we have 2NO2, which is in here. 2NO, then 2NO cancels out from the reactants and products. That's why we don't see it in the overall reaction. So NO is intermediate. So 2NO and 2NO they cancel each other. So NO plus 2O2 is going to give us 2NO2 gas phase. So basically we just simply add these two chemical the enthalpy changes. So 180 plus negative 112 is going to give us 68 kilojoules. So 68 kilojoules, it is positive. So it means that the overall reaction, as you see in here, is an endothermic reaction. So that's how we use Hess's law. Let's see another example. So this example is quite easy as well. It says calculate delta H using enthalpy change. It says graphite and diamond are two forms of solid carbon. Graphite is a soft, black, slippery material that is the substance in pencils that makes marks. On the other hand, diamond is a hard crystalline substance used in making jewelry. Calculate the enthalpy change for the conversion of graphite to diamond, which is C graphite in solid form to C in diamonds in solid form. We have two equations. Based on these two equations, we need to find out this enthalpy change. C in graphite plus O2 is going to give us CO2 in gas phase. Delta H is negative 394. And the other one is C in diamond plus O2 is going to be CO2, and it's going to be negative 396 kilojoule. So both of these reactions are the combustion reactions of graphite and diamond. Now let's look at here and see how we need to rearrange these two reactions in order to find out the delta H of the first reaction. So here we have graphite on the reactant side. We have graphite here in reactant side as well. But if you look at the diamond, we have it in the product side and the overall reaction. This one we have it in the reactant side. So in order to move it to the product side, sorry, you need to reverse it. So it's going to be CO2 gives us O2 plus C diamond in solid form. So when you reverse the reaction, the delta H is going to be, the sign of delta H is going to be reversed as well. So in here we have negative 396. It's going to be positive 396 then, because we reversed it. Product is going to be the new reactants, then reactants is going to be the new product. So right now we have this one and this one, and then when you add these two, CO2 and CO2, because one of them in the product side, one of them in the reactant side, they cancel out. We have O2 in the reactant side, and here O2 in the product side, they cancel out as well. So we have just carbon in graphite form converts to carbon in diamond form, and then this delta H we add these two, 396, subtract 394, or plus negative 394. It's going to be positive 2 kilojoules. So this is the overall enthalpy change for this chemical reaction. Let's see the next example. So in this example, ethane gas C2H4G is the raw material for the synthesis of the plastic polyethylene. Engineers designing a process to make ethane from ethane gas C2H6 gas need to know the change in enthalpy of the desired reaction represents by the following balanced chemical equation. So C2H6, which is the ethane gas, gives us C2H4, which is ethane gas, plus H2, and all of them are in gaseous phase. The engineers have the following thermochemical equation. First of all, ethane plus 3.5 oxygen is going to give us 2 CO2 plus 3 H2O in liquid phase. Is going to be delta H is negative 1559 kilojoule. Second one is C2H4 plus 3 oxygen is going to give us 2 CO2 plus 2 water. It's going to give us negative 1411 kilojoule. And the third one is 2H2 plus O2. It's going to give us 2H2O in liquid phase. And delta H is negative 572 kilojoule. So in order to get to this overall reaction, let's look at this here. So first of all, we have ethane in here. That's good. But what about here? This one is supposed to be reversed because we have ethane gas or ethylene gas in the product side. So I need to reverse this one. So it's 2 CO2 plus 2 H2O liquid is going to give us C2H4 gas plus 3 O2 gas is going to give us delta H equals to 1411 kilojoule. And it's in liquid. That's good. So what happens to the last equation? On the last equation we have H2 plus oxygen is going to give us H2O. So H2, and here we have H2, it means that we need to reverse this one as well. So it's going to be 2H2O liquid. It's going to give us O2 plus 2H2. Delta H is going to be positive 572. Because we reversed that, we need to change the sign as well. But as you see here, H2 is 1, the coefficient is 1. The coefficient of H2 here is 2. So we need to divide everything by 2. So it's going to be H2O liquid is going to give us 1/2 O2 plus H2. Because we divide this one by 2 is going to be 1. Delta H is going to be 572 divided by 2, which is 250, 286. Let's check it with the calculator. 572 divided by 2 is 286. Yeah. Kilojoule. So now we have this chemical reaction, we have this one, and we have the first one. Now if we add these three reactions, 2 CO2 and TCO2 cancelled out, 3 H2O with 2 and 1 H2O cancels out. We have 3 oxygen here and half oxygen in here in the product side, and we have 3.5 in here. So 3.5 can cancel out with 3.5 in the reactant side. So what is remaining is C2H6, C2H4, and H2 in here. It's just going to be what we have in the overall reaction. So delta H of the reaction is going to be negative 1559 plus 1411 plus 286. That's going to be 138 kilojoule. That's going to be enthalpy change for formation of ethane gas from ethane gas. Okay, next example, it says consider the following thermochemical equations. Ammonia, NH3, gas phase, gives us 1/2 N2 plus 3 over 2 OH2 is going to give us 46 kilojoules. The second reaction, 2H2 plus O2 is going to give us 2H2O, and delta H is negative 484 kilojoules. Calculate delta H for the reaction represented by the following equation. So the overall reaction is 2N2 plus 6H2O in gas phase is going to give us 3O2 in gas phase plus 4 ammonia. So in this case, what we're going to do, we're going to find out these reactions in here. We have NH3 in here, but in the overall reaction we have NH3 in here and in the product side. So we need to reverse it and multiply it by 4. So I'm going to start from here. 1 over 2 times 4 is going to be 2N2 in gas phase, plus 3 over 2 times 4 is going to be 6H2 gas phase is going to give us 46 times negative 4, which is going to be negative 184. Check it one more time. 46 times 4 is going to be 184. Yeah. Negative. It was positive, so we multiply that by negative 4. So we get negative 184 kilojoules. Now, we have 2H2 plus O2 give us 2H2O. Let's look at the overall reaction. In overall reaction, we have H2O in here, and we have O2 in here. So it means that we need to reverse this one as well. How? We reversed it and we multiplied that by 3, because we have O2, 3O2, 2H2O, 6H2O. So we reverse it and multiply it by 3. So that's going to be 6H2 plus we needed to reverse it as well. So I'm going to write it from here. 6H2O gives us 6H2 plus 3O2 gives us negative 484 times negative 3. 484 times 3 is going to be 1936 kilojoules. So that's gonna be, when you add them, it's gonna be 2N2 plus 6H2O. That was the first reaction. I forgot to write the NH3 in here, which is 4NH3. So when you add them, these two, we have 6H2 and 6H2 cancelled out. And what else? We have 2N2 in this side, 6H2O. That's exactly what we have in the overall reaction. And we have 4NH3 plus 3O2. Perfect. So we just add them all. So overall reaction is going to be negative 184 plus 1936. So 1936 minus 184 is going to be 1752 kilojoule. So that's going to be the overall reaction. And since it is positive, it means that we are dealing with an endothermic reaction. Now let's look at this example. Consider the following thermochemical equations. We have 3 equations here. 2ClF plus O2 is going to give us Cl2O plus F2O. We have the delta H 167.4 kilojoule. 2ClF3 plus 2O2 is going to give us Cl2O plus 3F2O is going to give us delta H equals to 341.4 kilojoule. And the third one is 2F2 plus O2 is going to give us 2F2O, and delta H is negative 43.4. Calculate delta H for the reaction represented by the following. So the overall reaction is like that. ClF plus F2 is going to give us ClF3. So we have ClF, but we have 2 in here. So we right away keep it the same here, but we divide everything by 2. So ClF plus 1 over 2 O2 give us 1 over 2 Cl2O plus 1 over 2 F2O. That's give us 167.4 divided by 2. That's 83.7 kilojoule. ClF3 we reverse it and divide it by 2. So it's going to be 1 over 2 Cl2O plus 3 over 2 F2O. It's going to give us F3 plus O2. That's going to give us negative 341.4 divided by 2. That's going to be negative 170 kilojoule. Then we do this one here. 2F2 plus O2 is going to give us 2F2O. That's going to give us negative 43.4 kilojoule. So when you add them, this one and this one cancels out. We have 3 over 2, 1 over 2. Actually, since we have F2 here, we needed to divide it by 2 as well. This guy, 43.4 divided by 2 is going to be 21.7. So we have 1 over 2 and 1 over 2 and 1 in here, so this cancels out, and we have F2O, half of it, 1 in here, and here we have 1.5, so these 3 cancels out. We have CLF3, and we have F2 in here, so we add them all. It's going to be 83.7 minus 170.7 minus 21.7. So that's going to be 83.7 minus 170.7 minus 21.7. That's going to be negative 108.7 kilojoule. That's the reaction. It is exothermic. It is negative, so it's exothermic reaction. So that's how we find out the enthalpy change for this reaction. Let's see another example. Next example, it says if iron trioxide is heated with carbon monoxide, carbon dioxide and metallic iron are produced according to the following reaction. The equation is Fe2O3 in solid form plus 3CO, carbon monoxide, in gas form. It's going to produce 2Fe in solid form plus 3 carbon dioxide, CO2, in gas phase. Determine the enthalpy of the reaction given the reactions as below. C carbon in graphite form plus half of oxygen is going to produce CO, carbon monoxide. Delta H is negative 110.5 kilojoule. Next one is C carbon graphite plus O2 is going to give us CO2. Delta H is going to be negative 393.5 kilojoule. And the third one is 2Fe plus 3 over 2O2 is going to give us Fe2O3. Delta H is negative 824.2 kilojoule. So what should we do now? We basically have Fe2O3 on the reactant side and Fe2O3 on the product side in here. So I need to reverse this one. Fe2O3 2FeS plus 3 over 2O2. Delta H is going to be 824.2 kilojoule. The negative is going to be positive. Then we have CO in here. So we reverse this one and multiply that by 3. So 3CO gives 3C in graphite form plus 3 over 2O2. It's going to give us positive 331.5 kilojoule. And what else we have? We have C in graphite form plus O2 is going to CO2. So we need to keep it like that because we have CO2 in here. We need to just multiply it by 3. So we have 3 C in graphite form plus 3 O2 give us 3 CO2. Delta H is going to be 3 times 393.5. It's going to be negative 1180.5 kilojoule. So we add them all. These 3 and this cancels out. We have 3/202, 3/202, 3/202, 1.5, 1.5, and 3 in here. They all cancel out. And we have Fe2O3 plus 3CO is going to give us T2Fe plus 3CO2. So it's going to be delta H. It's going to be 824.2 plus 331.5, 118.0. It's going to be 824.2 plus 331.5 minus 1180.5. It's going to be negative 24.80 kilojoule. So that's how we calculate for this reaction. Next example is liquid hydrogen N2H4 in liquid phase is a rocket fuel. It combusts in oxygen gas to form nitrogen gas and liquid water. So the reaction is N2H4 plus O2 is going to be N2 plus 2HO2 in liquid phase. Use the following thermochemical equations to calculate the enthalpy change for the combustion of liquid hydrogen. We have 4 reactions here. 2 ammonia plus 3N2O gives us 4N2 plus 3H2O in liquid phase. And the enthalpy change is negative 1010 kilojoule. NO2 plus 3H2 is going to give us N2H4 plus H2O, and it is negative 317. 2NH3 plus half oxygen is going to give us N2H4 plus H2O, give us negative 143. H2 plus half oxygen is going to give us H2 in liquid phase, negative 2H6. So we have N2H4, oxygen, nitrogen, and H2O in liquid phase. So this one is good the way we see it. These two has N2H4, N2H4, so we definitely need to reverse them. And here we have N2H2O, and here we have ammonia. So we need to keep it like that as well. So looks like we need to keep these two the way we see it and reverse these two. So yeah, let's reverse it. N2H4 liquid plus H2O liquid is going to give us NO2 plus 3H2 370. N2H4 plus H2O liquid 2NH3 plus half O2 is going to be 143 kilojoule. So these two are reversed. Then we have this guy and this guy. N2, let's keep it the way we see it. We have 2NH3 plus 3N2O gives us 4N2 plus 3H2O liquid. Delta H is negative 1010 kilojoule. So what else we have? We have H2, and here we have H2, so it means that we need to multiply this one by 3. So we have 3H2 plus 3/2O2 gives us 3H2O liquid. It's going to be 286 times 3, 858 kilojoule. Now I see I have 3H2 here, 3H2 here, but we have 3 over 2 oxygen. Here we have 1 over 2. So it means that I need to multiply the second equation by 3. 3, 6, 3 over 2. So this one times 3, 143 times 3 is going to be 429. So we have 429 kilojoules. So now let's see what we have. These two cancels out. 3 cancels out. We have liquid here, 3H2O. 3H2 cancels out. We have to multiply the first equation also by 3. So I'm going to make it 3 times 3 times 3. Actually, we didn't need to do that, so we keep it the same as, because if I multiply it by 3, I cannot cancel it with this guy, so leave it like that. So let's see what we have now. We have NO2 here. So in here I need to multiply it by 3 one more time. So that's going to be 9. This one is correct. This one is correct as well. What about here? This one, we didn't multiply it by 3. So this one is 3. Yeah. Let me write it because it's too messy. Let me write it one more time. So we have 2NH3 plus 3N2O gives 4N2 plus 3H2O. Delta H is negative 1010. We multiplied this equation by 317 was it? So I multiplied that by 3, so 3, and this one was 3, and it's gonna change to 9. So I multiplied this one by 3 as well. Then the third one is gonna be, I'm gonna multiply it by 9. 9H2 plus 1 over 2 times 9, 9 over 2O2. It's gonna give us 9H2 liquid. So 9 times 858. It's gonna be negative 7720. And finally we have N2H4 plus H2O. Liquid again gives us 2NH3 plus 1 over 2O2. Delta H is 143 kilojoules. Now this cancels with this one. We have H2O, H2 cancels out. 1 and 9 is going to be 8 H2O. We have half, and we have 9 over 2 is going to be 4 O2 in here. We have 3 and 1, 4 and 2H4 gives us NO2, and NO2 cancels out. And 2NH3 and 2NH3 cancels out. We have 4 and 2 as well. So we need to divide everything by 4. So negative 1010 plus 3 times 317 minus 7722 plus 143. That's gonna be divided by 4 is going to be negative 1909.5 kilojoule. So I divided by 4. When I calculated, I divided by 4 because 4 has to be divided by 4. 4 divided by 4. 4 divided by 8 divided by 4 is going to be 2. So the final answer is negative 1909.5 kilojoules.